All right, so what I've got here on this portable TV cart is a DC power supply putting out 12 volts to this timing GPS receiver. This is a Nokia FYGM. And the reason I'm on this cart in the first place is because I needed a GPS lock. There's my antenna. And then I have a scope set up here, viewing or displaying the output of two different signals on here. And there are two different ways to visualize the same thing. So one of them, channel 1 on the scope, so this top channel, is the PPS coming directly off of the U-Blocks module. You can see there, that bottommost pin, that bottom left pin, that is channel 1, coming straight off there, getting tapped into, I think it's this sort of middle wire that's going into this DIN connector, that's going through all this, and is that brown wire right there. The white wire, which is channel 2, is using, is connected to one of the original signals that's plugged into that connector. Of those 3 wires, it's actually the bottommost wire. So this particular unit, on the bottom of it, has 2 RS-485 transceivers, which create very high reliability differential signaling. And for UART, so for the text, binary data, I should say, that goes in and out of the GPS, we're just using straight UART through these 2 pins here that are wire wrapped, because the pins, the UART data by default goes through that chip right there, which is an 8051 microcontroller, which is doing some processing on that UART data before it sends it to the RS-485 transceiver. So we're not interested in that. However, the PPS data, so the pulse per second signaling that comes out of that pin there, that goes into an RS-485 transceiver and gets sent into a differential signal. But what I realized is, and as this oscilloscope output proves, the signals are the exact same. Granted, you have to get the right one. So since it's a differential pair, one of them goes positive and one of them goes negative. So in this case, the pin that I've connected to, which is this bottom, it's the second up. I think it's PPSY on the pin. I have to double check. But that is the positive running pair. And you can see very clearly that they are nicely in sync because it's the exact same piece of data. But anyway, the whole point of all this is, if you wanted to use a Nokia FYGM for normal purposes, other than connecting it to a Nokia cellular radio base station, instead of having to solder that wire onto this U-Blocks module, you can literally take the PPS signal just straight off the connector as it is, so you don't have to do that micro soldering. You can take that signal straight off. So that's pretty cool. That makes this whole process actually quite a bit easier, because that means if you want to use one of these for purposes other than using a Nokia cellular base station, all you have to do is disconnect 2 of the wires from this connector, 2 of these white wires, and reroute them to these 2 middle pins. The rightmost pin is transmit, that's data coming out of the GPS receiver, and then the left middle pin is data being received into the GPS receiver. One trick, though, is the fact that you can see that little blob of solder there. A jumper resistor is left off on production units, so you have to solder those 2 pads together with either a very short piece of wire or a blob of solder or something like that. But anyway, those 2 things are a lot easier to do than soldering a wire directly onto the PPS pad. So that just makes this a whole lot easier.